This video is going to be a short one about solving polynomial equations using factoring, quadratic formula, and using difference of cubes and sum of cubes. So if you want to solve any polynomial, I would set it equal to 0 and then factor. That's the key. So here's an example. We have the polynomial equation we want to solve by factoring or using factors. So first step, we have to set it equal to 0. So we're going to have 2x to the third minus 5x squared minus 3x equal 0. We're going to look for a GCF, which is x. So we have x, 2x squared minus 5x minus 3 all equal to 0. Step 2, we have to set each polynomial term equal to 0, or each factor to 0. So we're going to set the x equal to 0 and this quadratic of 2x squared minus 5x minus 3 equal to 0 and solve. So we know one solution is x equals 0, the other for the quadratic, I'd use quadratic formula, or you can use factoring by box method to see if that works by multiplying 2 times negative 3 to get negative 6, two numbers that multiply up to negative 6 and add up to negative 5, which would be obviously 6, negative 6, and positive 1. So let's do it that way. We have 2 times negative 3 equals negative 6, so we need m and n to give us negative 6, but add up to negative 5. So those two numbers would be negative 6 and plus 1. So using our box method and factor, we have 2x squared minus 6x plus 1x minus 3. Factoring going across, we have just 1. Factoring going across, we have 2x. Factoring going down, we have x. Factoring going down, we have negative 3. So we have 2x plus 1, x minus 3 equals 0. So we factored. Now we set 2x plus 1 equal to 0, x minus 3 equal to 0, and solve. So we have 2x equals negative 1, x equals negative half, and here x equals 3. So our solutions would be x equals 0 is a solution. X equals 3 is a solution, and x equals negative half is a solution. Again, here's the full view. Again, I factored 2x squared minus 5x minus 3. You could also use quadratic formula and still get negative half and 3. Here's another one. What are the real and imaginary solutions for the polynomial equation? So we have to set it equal to 0. So I'm going to have 3x to the fourth minus 6x to the third plus 12x squared equals 0. GCF is x squared. So I have, well, it's 3x squared, because I know that 3 goes into both 6 and 12. So pull out the 3x squared, and I get x squared minus 2x plus 4 equal to 0. So we set 3x squared equal to 0. So x equals 0 in this case. X squared minus 2x plus 4 equals 0. Here I'm going to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Solving, we get 2 plus or minus the square root of 2 minus negative 16 all over 2, which simplifies to 2 plus or minus the square root of 2 minus 16 is negative 14 all over 2. Simplifying, we have 2 plus or minus, we have a negative inside the square root, pull out the I, all over 2, which simplifies down even further. 14 is 2 times 7, so that is, there's no perfect squares going in the 14, but this is 2 over 2 plus or minus I square root 14 over 2, which simplifies down to 1 plus or minus I square root 14 all over 2. So we have our solutions, which we have one real solution, 0, and we have two imaginary. We have 1 plus I square root 14 over 2 and 1 minus I square root 14 over 2. The next new way to factor is sum and difference of cubes. Here, if you have a perfect cube plus a perfect cube, here is your factored form. And if you have a difference of cubes, here's your factored form. Now remember, a perfect cube is anything that can be rewritten as to the third power. So we know 8 is a perfect cube because it can be rewritten as 2 to the third power, to a cube. We know that 27 is a perfect cube because 3 times 3 is 9 times 3 again is 27. So again, perfect cubes are any number that can be raised to the third power. And you can factor. So we're going to do an example. So we're going to do x to the third plus 8. And we're going to have to factor. So rewrite it as sum or difference of cubes. So we're going to write this as 1x to the third plus 2 to the third. And here's our a, there's our b term. So using the sum of cubes, we're going to write it as a, 1x plus b, which is 2, times a squared is x squared, minus a times b, which is 2x, plus 4, because b squared is 4. And there is your factored form. Right there. We'll try another one and use it to solve. So we have x to the third minus 1 equals 0. We know we have 1x to the third, it's its difference of cubes, equals 0. So we're going to have to use our difference of cubes and factor it. So I know it's going to be minus and all pluses. So 1x minus 1, and we're going to have x squared plus 1x plus 1. So now since we're solving, we have to set each polynomial term equal to 0. So here we have 1x minus 1 equals 0, x equals 1. Then we have x squared plus 1x plus 1 equals 0. I'm going to use quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Simplifying, we have 1 minus 4 all over 2. Simplifying even further, we have still negative 1, negative 3 all over 2. Negative inside the square root, pull out the I, plus or minus I square root 3 all over 2. And there is our solution. So x equals -1 plus or minus I square root 3 over 2, and x equals 1. Those are our solutions. If you have any questions, see me after school or before school.